Hey math kids, today we're going to talk about velocity. And so to get started with that, we have average velocity. That's going to be just change in displacement divided by change in time. So in other words, delta S over delta T. Okay? Or we can think of it like our slope formula, which would look more like this. So basically our y values subtracted over our t values, which are our x values. So it's really just this formula, which is our slope formula. Okay. So if we just have displacement and we use that as our, it's just the change in our displacement with respect to time. And so if we are going to do, let's jump into this example. It says a particle moves in a straight line with displacement from the origin given by s of t equal to 3t minus t squared, and that's measured in meters, and t is in seconds. Okay, find the average velocity for the time interval from t equals 2 to t equals 5. Okay, so what we're going to do is up here, we're going to use this formula. And so we're going to find s of 5 minus s of 2. So s of 5 minus s of 2. And then we're going to put that over 5 minus 2. So s of 5, I need to plug that into this. And so I'm going to get 3 times 5 minus 5 squared. And then subtract s of 2. So 3 times 2 minus 2 squared. And then I'm just going to simplify that to a 3. Okay, so this is 25. And then this is 15. So 15 minus 25 is going to give us negative 10 minus right here. And then this is 4. This is 6. 6 minus 4 gives us 2. That's still over 3. We get negative 12 over 3, which gives us negative 4. So that's the average velocity over that time interval. Okay, now it says the instantaneous velocity at t equals 2 seconds. So t equals 2 seconds, instantaneous velocity. So what we're going to do, if we take the derivative of displacement, so we're thinking of this like ds dt, then we'll get the instantaneous velocity at t equals 2. And so we take this function, take the derivative of that. That's just going to be 3 minus 2t. So that was s prime of t, or v of t. Same thing. And then if we want to look at it specifically at t equals 2, we just plug in a 2 for t and simplify that. 3 minus 4 gives us negative 1. And so the instantaneous velocity is negative 1 meters per second. I should have written meters per second on this one as well. And that's everything for that problem. Now, we're going to move on to another one. The velocity time graph. So I got to draw this thing. Your book's going to be a better version of this. 10, 20, 30, 40, 50, 60. So it looks something like that. Then we get 0.1, 0.2, 0.3, 4, 5, 6. Then we have one at 50 right there, and then 0.3 and 50. Then we go down to 30. And then we stay at 30. And then we go to 0. Okay. So we're given this. It says the velocity time graph for a train journey is illustrated in the graph alongside, or this graph right here. Find the total distance traveled by the train. So all we have to do is break this up into areas, and that's going to tell us the total distance. Because once again, this is velocity time. So this is time, this is velocity. And so if we're given velocity and we want to know distance or displacement, we go back. So if we had that, we would take the antiderivative, which is like an integral, which is the area under a curve. And so if we break this up like this, so that's how I'm choosing to break it up. So this is going to be 0.1 by 50. And so we have 0.1, so 1/2 base times height. 1/2 base times height, because that's a triangle. Then this is going to be 0.2 by 50. So then we're going to add that. So 0.2 by 50, since that's a rectangle, it's just length times width. Okay, now I'm going to do this triangle. So this is 0.1 by, it goes 30 to 50, so that's 20. And so once again, it's going to be 1/2 base times height. Keep going, and then we'll add this rectangle, which looks like it's 30 by 0.1. So length times width, 30 times 0.1. Now we're going to do this rectangle, which is actually the same. So 30 times 0.1, because the base is 0.1, the height is 30. And then we have this triangle, which, what color should I use? Let's use red again. So that's going to be 30 by 0.1, but it's a triangle, so it's 1/2 times 30 times 0.1. All right, so basically we plug this all into a calculator, hit enter, and we're going to end up with 21 kilometers. Okay, I forgot to tell you this is given in kilometers per hour, and that's how we know the final units are kilometers. Okay, so this was hours, and this was kilometers per hour. Okay, so once again, just find the area under the curve, and that's how we're going to transform a velocity graph into a displacement answer, or a distance answer. Okay.